Very good morning to everyone. Good afternoon, good evening, wherever you are in the world at this moment. My name is Suresh Neethirajan. I'm an associate professor at the Faculty of Computer Science with a joint appointment in Faculty of Agriculture, Dalhousie University. I also hold a research chair position in digital livestock farming. Before we start any meeting here in Canada, what we do, what we call as land acknowledgement, I will just acknowledge by reading a statement expressing gratitude to the space that's provided to us. At Dalhousie University, we acknowledge that we are on Mi'kmaq, the ancestral and unceded territory of the Mi'kmaq people. We pay our respects to the indigenous knowledges held by the Mi'kmaq people and to the wisdom of their elders, past and present. We also acknowledge the histories, contributions, and legacies of African Nova Scotians who have been here for more than 400 years. We are grateful to live, work, and learn on the territory and recognize our responsibility to respect and uphold the inherent treaty rights of all indigenous peoples. Today, we have an exciting day. We have a list of eminent speakers from all over the world, Europe, North America, here to share their knowledge and wisdom to us. It's so exciting to be sharing and learning about the interface of human-animal-computer interfaces, especially from the farm-animal perspective. Now I invite Professor Stacey, who is a full professor from the University of Guelph, to introduce herself before we start this event.
Should I use your mic? So we're sharing tech. Good day, everyone, wherever you are, wherever you're joining us from. My name is Professor Stacey Scott. I'm a full professor in the School of Computer Science at the University of Guelph, and I'm also the graduate director in the School of Computer Science at Guelph. And I'm very excited about today's program. When Suresh and I first started talking about this, wasn't really sure what the program would end up looking like, and I'm so excited to see all the amazing speakers that we have for you today, and all the diversity of people who are here to join us. Really excited to see this people from all different disciplines coming together to talk about this very important topic. My area of research is generally in the area of user interfaces for emerging technologies. And when I joined the University of Guelph, which is one of the preeminent food and veterinary universities in Canada, I really started thinking about the intersection of how technology could improve animal health and welfare. And so I'm so excited to see these conversations today. So I'm going to hand it back to Suresh to introduce our first speaker. Have a great day, everyone.
Okay, thank you, Stacey. Our first speaker is Professor Marian Dawkins. Professor Marian Dawkins is a renowned figure in the animal science community. And while she needs little introduction, I would like to provide a brief overview for the benefit of younger folks and the new students who are in the animal science department. Dr. Dawkins is a professor of ethology and a British biologist at the University of Oxford. Professor Emeritus. Her research interests include vision in birds, animal signaling, behavioral synchrony, animal consciousness, and animal welfare. She has been instrumental in establishing animal welfare as a field of scientific research by developing objective tests that quantify the choices and demands of animals, combined with scientific measurements of relevant biomolecules. This work has made it possible to consider the point of view of animals in ways previously thought impossible. She has demonstrated that improvements in animal welfare can translate into benefits, including economic ones for humans. Dr. Dawkins has authored several books and published extensively in the animal welfare domain. One of my personal favorites is Why Animals Matter, Animal Consciousness, Animal Welfare, and Human Well-Being. This was published in the year 2012. Widely admired for the clarity of her thinking and writing, Dr. Dawkins is a foremost authority in also the field of animal behavior. In recognition of her contributions to animal welfare, she was appointed Commander of the Order of the British Empire in the year 2014, New Year honors, and also elected as a Fellow of the Royal Society in the same year for her substantial contributions to the improvement of natural knowledge. We're really excited and thrilled to welcome Professor Dr. Dawkins, who brings several decades of knowledge and wisdom to us. Her presence here is truly an honor. Most welcome, Dr. Dawkins. The floor is yours.
Always this problem of I'm not. Yeah. Ah, right. I'm with you. I hope everybody can hear me. Well, Suresh, thank you very much for that rather embarrassingly nice introduction, and good day to everybody wherever you are. I want to talk about how we can make sure that animal welfare is put into smart farming. I think that there is an issue because not everybody agrees it's a good thing for animal welfare. So what I'm going to do is, first of all, to talk a bit about what smart farming is and what its benefits are and why people object to it. Then I'm going to address this main question of how we can make sure that when we use technology in farming, animal welfare is made a priority, both in theory, but then I want to come on finally to talk about how we can actually ensure that the promise of smart farming actually results in improved animal welfare in practice. So what is smart livestock farming? It covers a huge range of different technologies that monitor and manage the keeping of farm animals. So it includes sensors on the animals or inside the animals that might be measuring their movement, their body temperatures, their heart rate, and so on, as well as sensors in the environment measuring temperature, humidity, gas composition, and so on. It also includes control systems that might actually be controlling the environment of the animals. And
Dr. Dawkins?
yes,
we can't see your slides.
You can't see my slides.
No, we just see your video.
Yeah, there is a green button in the middle called share. If you click that.
Yes, I've done that.
Now we can see your screen, desktop screen.
Yes. Screen sharing. So then I can't see how to...
email.
Sorry?
We're hitting your email.
Screen sharing. Right, okay. Can you see that?
Yes, we can, yeah.
Yeah. So
you can see that. Okay.
Yeah, now we can.
Slideshow. Right.
Perfect. Thank you.
You can see that now, can you?
Yes.
Yeah.
Oh, you can see that. Okay, that's fine. And finally, of course, it will increasingly involve the use of artificial intelligence. I just want to make one slightly mundane point about the fact that this varies very much about which livestock sector you're looking at. The term precision farming originated with crop agriculture, with the idea that instead of treating the whole field as the same and administering the same amount of water and nutrients and pesticides on the whole field, you had a more precise targeting of these things to particular parts of the field or particular plants. so that instead of, if there was some parts of the field that were wetter than others, you wouldn't waste water on the other side. And that, that has been very successful and taken up quite widely. When the term precision livestock farming was coined, it is clearly appropriate for species like cows or pigs, where again, there is precision onto particular individuals. So in the dairy industry, for example, individual cows are given their own individual diets. They're treated with their own medication, and so on. Whereas this is not appropriate for poultry farming, where still people are looking at flock level. All the management decisions about feeding and lighting, vaccinations and so on are taken at flock level, not individual bird level. I hope that one day, of course, it will be at individual bird level, because welfare is an individual matter, but not a flock matter, not a group matter. So it isn't appropriate to talk about precision poultry farming yet. I hope it will be one day. So I'm going to talk about smart farming, not precision farming, for that reason. If we look at the future of livestock farming, we can see that the projections are that it is going to increase, with the biggest increases in poultry, and so that this is what is being looked at, an expansion. And the pressures on livestock farming now are immense. The pressures on farming are to increase volume and to be more efficient, to reduce medication, particularly to reduce the use of antibiotics, but of course, to maintain animal health, to improve food quality and food safety. There are pressures from people worried about the environmental impact of farming, to reduce the impact. There are many pressures to improve animal welfare, while of course keeping up efficiency. And farmers are expected to do all of this while dealing with increasing costs of fuel and food, ever increasing regulations, shortage of skilled labour, epidemics such as bird flu, pressure to reduce meat consumption altogether, and competition from plant-based and lab-based meats. So it is a difficult time to be a livestock farmer. And for this reason, people are thinking that many benefits could come from technology, from smart farming, that you could have 24/7 monitoring of health and welfare, which could lead to earlier detection of health and welfare problems. If you could do that, you would reduce the amount of medication, because people would be less tempted to use medication prophylactically. They would target it more. If you had animals that were kept with higher health status, you'd have healthier food for humans. You'd have greater efficiency if you had lowered mortality. You would have reduced environmental impacts through less waste. You'd have an improved working environment for staff. You would have improved biosecurity, because you wouldn't have so many people moving around from house to house. You could have really improved information for consumers, because they could actually see what was happening to the animals. And you would, of course, provide superb data for large databases that could be subjected to artificial intelligence. So there are potentially many benefits from applying technology. But of course, there are objections. And in particular, people are worried about the fact that greater technology will mean greater intensification, which they see as very much leading to poorer standards of animal welfare. So Peter Stevenson is arguing there is a danger that in facilitating the management of intensive systems, this will entrench the use of systems where the potential for delivering good welfare is reduced. And Frank Hutchins has also argued we need to be on our guard that we're just not going to be asking the animals to pay the price. And I think what people are worried about is that the damage to animal welfare will come from larger group sizes, more indoor housing, less human contact with animals. And I think it's a fair criticism that these promises of technology have not yet been demonstrated in many fields. In some fields they have. The dairy industry, for example, has taken up technology in a big way, but in other areas, the advantages are not yet clear. The promise is there, but we don't know whether the potential is going to be fulfilled. So I now want to turn to how we might make it more likely that the new technology will improve the welfare of animals. And I think there are two things we need to do. First, we need to define welfare in a way that everybody can agree on. If you had a definition of welfare that the scientists agreed on, but the public didn't think was any good, well, then you're not going to be very successful in convincing people that technology is improving welfare. You've got to have something that everybody can buy into. And secondly, if we're going to put welfare into smart farming, we're going to have something that's measurable by technology. It's no good having a vague idea of, I don't know, mental health in animals or something, if you can't actually tell a machine what to look for. So we need good, clear definitions of welfare. And then we need to actually show that these smart farming measures really improve animal welfare. So when people define animal welfare, as you probably know, one of the attempts to do this, originating in the 1970s, was the five freedoms, which were put forward by the Farm Animal Welfare Council. And these were freedom from hunger and thirst, freedom from discomfort, freedom from pain, injury, or disease, freedom to express normal behavior, and freedom from fear and distress. And this was a major step forward because it began to encapsulate what people might actually mean by good welfare. But more recently, there have been criticisms of the five freedoms, largely because they are a bit negative. They're talking about absence of freedom from hunger and thirst, making sure the animals are not hungry, not thirsty, not uncomfortable, not in pain, not injury, not fearful. Now, only one of the five freedoms, freedom to express normal behavior, is positive. So more recently, people have tried to be more positive about the definition of welfare that they use. And you now find in many supermarkets, retailers, animal welfare charities, they use the five domains, which originated from David Mellor in New Zealand. These have a lot in common with the five freedoms, but as you will see, they're not exactly the same. The fifth, the mental state, the good welfare, in the middle there, and then the idea is that various things contribute to that positive mental state. So the animals need the right behavioral interactions with humans and with other animals. They need the right physical environment, they need health, and so on. And all of these contribute to what we mean by good welfare, the state of being in a good welfare. Now, I've got nothing against the five domains, except the fact that they're quite abstract, and they actually make it quite difficult to know what to look for. I mean, which behavioral interactions are going to contribute to good welfare? Which environmental conditions are going to contribute? So they leave an awful lot out of, still to be answered. So for that reason, I put forward the idea that we could précis both the five freedoms and the five domains into two questions or two requirements, which are not, I must stress, they're not alternatives. They're simply trying to make more substantial the rather abstract ideas that are in the five domains. And these two things are that the animals are healthy and the animals that have what they want. Now, you can see on the five freedoms that the first three of those five freedoms are all to do with animal health, and that health, nutrition, and so on are also present in the five domains. So I think it's fairly obvious that good physical health forms the foundation of good welfare. And I'll just take a few minutes just to explain why animals having what they want gives us the other bit of what we mean by good welfare. Clearly, there's more to good welfare than just physical health. If we talk about mental health, it's incredibly difficult to tie down and actually measure it and put it in a situation that is suitable for technology. But what we can say is if animals have what they want, then by and large, they will be in a positive emotional state. And if they do not have what they want, or they are forced to be with things that they don't like, then they will be in a negative emotional state. So what animals want is a kind of like a proxy for animals telling us whether they are in a positive or negative emotional state. That is, they have good or poor mental health. So, for example, if animals are forced to be in the presence of something they want to avoid or escape from, they will have negative emotions such as fear and anxiety. They will be in pain. They will be frustrated because they can see what they want, but they can't get it. They might be deprived. What they want is just nowhere to be seen. They may be bored. They want stimulation. But if they're in the presence of things that they want and want to repeat, then they will have emotions such as pleasure, contentment, satisfaction. Now, of course, none of us can be on the green side all the time. But what we mean by good welfare is that animals spend most of their time on the right-hand side of the line. And the great thing about the question, what do animals want, is we can ask them. And basically, we've got three methods of asking animals what they want. Will they use it? Will they choose it? And in particular, will they work for it? So, for example, if you want to know whether broiler chickens want an enrichment in the form of straw bales, you can ask, well, if you give it to them, do they use it? I mean, if they don't, you can't really argue that it's something that they want. But if they use it, sit on it, scratch in it, peck at it, and so on, you could say, well, they're using it, they're showing that this is something that they want. You can ask animals for a choice, obviously choice of food, but you can ask them what kind of bedding they like, what kind of lighting they like, even whether they want to be with other animals and so on. But most of all, and most perhaps persuasively of all, will they work for it? Will they make an effort to get what they want or to get away from what they don't want? And the obvious ways is they could press a lever or do something like that, or they could push weights. Chickens will push weights to get at perches and somewhere to dust bathe in. Or my favorite here, an example of cows that will push a button to turn on the motors of these rotating brushes and then groom themselves with it. And they will push down quite heavy gates in order to get to their brushes. They clearly will work. These are something they want and they will work for it. And these are some of the questions that animals have given. I mean, calves want social contact. Mink will work hard for water to swim in. Chickens want to feed in bright light, but possibly to rest in dimmer light. Cows will work for access to grooming brushes, as we've seen, and pigs want to escape even mild levels of ammonia. So we can actually ask the animals what sorts of things they want. And we can ask things like, which natural behavior the animals want to do. And sometimes people make rather sweeping statements that natural behavior is essential for good welfare. But some natural behavior, such as being chased by a predator, is entirely natural, but it may not be wanted. So we can actually find out from the animal-centered viewpoint, what they want and what is essential for their welfare. So if we go back to this and say that's why I'm arguing that animals are healthy and animals have what they want, actually cover what's in the essence of the 5 freedoms and the 5 domains. They actually cover, but do what people mean when they talk about physical health and mental health, but they do so in a way which is kind of grounded in something you can measure, and therefore something that would be looked for by technology. So, can we implement this definition of welfare into technology? Can technology help us to do this and help us bring animal welfare into technology? So let's begin with the first bit of the definition. As I mentioned, it's a first absolutely essential part of good welfare. And there are now many different applications for monitoring the health of farm animals, for diagnosing and predicting disease, and other health problems. I think it's worth pointing out that veterinary medicine currently lags behind human medicine in its application to these issues, but there is a huge potential for future applications of this. I'll just give you a couple of current examples, but I think this is just a glimpse of what is to come. So, for example, we now have automatic assessment of lameness in cows. And this can be done in a number of different ways. For example, you could have image processing of abnormal posture or abnormal gait from video, and that can be done automatically. You can measure the weight distribution between the different feet, and this is often done in so-called voluntary milking systems for cows, in which individual cows stand being milked, and while they're doing that, there will be pressure plates measuring the weight on different feet. And if there's a change in this from that individual cow, then this will be detected as something wrong with their legs or feet. It can be done by accelerometers. You can use accelerometers to look at the gait of the cows. You can look at thermal imaging where there is heat, where it shouldn't be, maybe. And you can look at things like changing in feeding behavior. If the cow is not going to feed as often as it previously did, then that might suggest that it's finding it difficult to walk to the food and so on. So there were now lots of different ways in which we can automatically measure lameness in cows. Here's another way, another measurement of health, automated assessment of broiler chicken health. Currently on broiler farms, the welfare assessment of broiler chickens is mostly post-mortem. That is, at the abattoir, they are assessed for various things like pododermatitis or hockburn. There are post-flock measurements of mortality, culls, and so on. But of course, if it's done when the birds, after the birds have been killed, then there's nothing you could do about the welfare while they're growing up. Sometimes there are audits in which people go onto the farm and perhaps measure the gait scores of a few birds, but that just gives you a snapshot of what's going on. And there's a large part of their lives, particularly this crucial early week when there is no monitoring. So clearly there is a need for monitoring the health of broiler chickens. And we've been developing a system which looks at the welfare of birds and acts as a kind of welfare sensor to be fed into smart farming system. It gives continuous camera monitoring and immediate on-farm processing. And it uses the optical flow patterns made by flock movement. So as the chickens move around, they make movement patterns which are picked up as optical flow and processed immediately. And these patterns of flock movement vary with flock health. So, for example, if you look at the optical flow patterns of flocks which have high mortality, you will find that the mean level of movement goes down, but the kurtosis, which is a measure of variation, goes up. If you look at flocks which have a high level of hockburn, again, you find that the mean level of optical flow goes down, whereas the variation goes up. With more footpad dermatitis, the mean level goes down, the variation goes up. And the more lame birds you have in a flock, you'll find that those flocks have reduced mean and an increased kurtosis. So unhealthy flocks move less. They have a lower mean, which is perhaps not very surprising because the birds are just constrained about moving, but they are also more variable. And we found that this higher variability is really key to giving you information about flock health. And the results are robust. They hold up over several continents, different systems, and we found that this applies right across the board. And although it's a flock level movement measure, it actually measures behavior at the individual level. This is work done by my very hardworking colleague, Sabine Gebhardt, in University of Bern. And we had cameras in houses, and she went round and set up this runway at the back of houses, and she measured how long individual birds took to walk down this corridor. And she used that as a measure of how well they walked. The longer they took, the less well they were walking. And what we found was that the birds that came from the flocks with the highest kurtosis of optical flow also had the worst average walking ability. So although it's a flock level measure, it clearly is measuring something important about walking at individual level. And the flock movement patterns also predict infection with Campylobacter. We had our cameras in a number of flocks and then collected fecal samples at 21, 28, and 35 days so that we knew whether those flocks were Campylobacter positive or Campylobacter negative. The green flocks are the ones that remain Campylobacter negative all the way through their lives. The blue flocks are the ones that turned positive at one of those times. And you'll see that you've got exactly the same pattern. You've got the lower mean and the higher kurtosis in the infected flocks. And this was remarkable for two reasons. First of all, because Campylobacter wasn't supposed to affect chickens. It was supposed to be a zoonotic disease. Only chickens were meant to be carriers for human disease, but clearly there's something odd going on with the chickens. But the even more interesting thing is that this separation occurs very early on. It occurs when the birds are less than a week old, even though when you test for fecal samples for Campylobacter by culture, you can't detect it before the birds are 21 days old. So the optical flow patterns were apparently picking up something really early on, weeks before it was detected by culture. So it's not merely giving information about current flock health, it's actually predicting future flock health. So we can plot each flock against other flocks. So a farm manager can see whether a flock is doing well or badly compared to others. And this is some flocks compared to an average of 85 flocks. And you can see here's a flock which had low mortality and low hop burn, and it came out as above average on our welfare measure. Whereas this flock, which had terrible mortality and bad foot pad dermatitis, right from the beginning, it was in problem. It was lower welfare than average. And basically what happens is that the farmer gets an update every day. So any flock that goes into the red is clearly a bit of a problem and needs to take notice of it. So I think the future of health monitoring is really good. And I think we can look forward to some major advances in flock health measuring. But the second part of good welfare, I was arguing, is do the animals have what they want? And I argued that asking, do animals have what they want, is a good kind of proxy for mental health measures. And I think there are three ways in which technology can help us to with animal welfare. It can help us to uncover what animals want. It can help us to give animals what they want. And it can also potentially help us to tell us how animals express their emotions, i.e. whether they've got what they want or whether they haven't got what they want. So, for example, technology can help us to discover what animals want. I said one of the main things we can find out is will they use an enrichment? And obviously, quantitative assessment of where the birds are, how many there are, how much time they spend interacting with each other and with the enrichment is hugely important. It's going to is revolutionized if you can automate the whole thing. If you have to sit there with your notebook recording when chickens jump on bales or wade through hours and hours of videotape. You know, you're not going to get the data, but if you can actually automate it all, you're going to get much, much better data and much better idea of how animals interact with things and what they use. And of course, we can also use technology to manage animals' access to these different resources. Again, enormously increasing what range of things can they can be offered. You know, will they work for it? Almost always involves some kind of technology to offer them and to make sure that we measure how much they work for it. And it can also help us to deliver to them what they want in this, we hope, improved environment. But the third way, I think this is maybe something for the future, is that we can actually use what animals want to interpret their body language and sounds and their gestures. So we can ask, once we know what animals want, what they like, what they don't like, we can ask, what behavior do animals show when they have what they want? Now, I've already shown one, and this, you can see this expression on the cow's face when she's got what she wants. And we can use this information so that we can sort of, as it were, crack the code of animals. And for example, we might have, this is the sound that chicks make. It's called a pleasure twitter. It's the sound they make when they have what they want. It's a little sort of twittering sound. Now we know that it's a pleasure twitter. We know that it's made by animals that have what they want because they've shown us that the things that they want, warmth, companion, food, and so on, they give it under these circumstances. But we can also say, what behavior do animals show when they have what they do not want? And there are a number of studies showing, for example, in cows, that the amount of eye white it increases when cows have negative emotions such as fear or frustration. If a cow can see her calf but can't get at it, for example. And similarly, we can see that we've got, I can't actually see that. We can see the sound a chick makes when it doesn't have what it wants, when it's cold or hungry or on its own. They give this ear-splitting noise. It's absolutely unmistakable. So we can actually begin to understand the body language of animals, which then means that we could supply farmers with a kind of manual, a kind of app, if you like, of how to interpret different behaviors. And just to show you what the future might look like, there's a study recently that used artificial intelligence to understand the language of animals. In this case, it happened to be orangutans, and it looked at the interactions between mothers and offspring. And instead of the people having to sit there for 600 hours and record what was going on, they left it to the technology to find out what was going on. And they were able to identify vocal signals and gesture types that they wouldn't have suspected otherwise. And one can see that this is going to open up an enormous range of ways of understanding animal body language. We can actually track it. It's kind of really going to give us a wonderful understanding, a much better understanding of animal language than we've had before. So those are some of the promises that smart farming holds out. But how can we actually ensure that all these promises are fulfilled, that it actually does improve animal welfare, and that that the critics aren't going to be right? Now, I think there are basically three things I think we could do and aim at doing that is going, I hope, would improve the chances that animal welfare will be a priority in the smart farming of the future. The first thing we can do is to start by emphasizing the common ground, i.e. Between good welfare and efficient farming, rather than areas of conflict. Of course, there will be areas of conflict. There may be enrichments that the animals would like, but the farmers say we can't afford it, or it's too difficult to clean, or whatever. So, but that's certainly true. What we need to do is emphasize what's in common. Then we have to develop the potential, demonstrate the potential on farms. And then I want to say a little bit about the possible use of AI and the use of big databases to improve welfare. So good animal welfare, okay, it may conflict with efficient farming, it may cost money, but there's an awful lot of things in which it actually ticks an awful lot of boxes of an awful lot of people and may actually result in greater efficiency. For example, just take low mortality. If you improve the welfare so much that you reduce mortality, you would have less waste, which would please environmentalists, and you'd have more to sell, which would then improve, please the economic balance sheet. If you had lower levels of injury, which would be another sign of good welfare, you'd have a higher quality product, probably better research. If you had lower disease levels, that would be through good. That all of these things are pluses. They're things that everybody can join into. They're win-wins. So it seems to me that we really need to push on this common ground, because that's going to be much more likely that we'll get good welfare into a technology than if we kept making out, oh, well, it's a conflict and so on. And my experience of talking to poultry producers and the big retailers is that they're perfectly willing to consider this, but they do have two constraints. First of all, they want evidence that the welfare is actually improved. And secondly, they cannot afford to introduce things that are going to cost them money and put them out of business. But they are very willing to consider new ways of looking at things. For example, I just happened to pick this up from a poultry site a few weeks ago, that there may be a conflict between slower growing birds and which have high welfare and efficiency. And people say, oh no, they're not nearly as efficient, we can't possibly afford. But actually, it may be that the slower growing birds have lower mortality rates, fewer problems, and so on, so that they actually could be more profitable. And I think the idea that people are inflexible, I think, is wrong. But I think we do need to push the efficiency side as well as the welfare side if we want the welfare side to be taken seriously. So I think that we really do need to do that. First of all, that means demonstrating the benefits of the technology, where benefits are not just welfare, not just financial, but we actually take into account as many things as possible. And that means on-farm trials, perhaps rather greater cooperation with industry than we've had up to now. And we need to measure welfare and the financial implications and a whole range of other things, that I think, in order to demonstrate the benefits. They're not just one benefit. There are lots of benefits, and whether or not the technology, the animal welfare is going to be improved, the technology designed to improve welfare is going to be included, will depend on there being demonstrable benefits of a right kind. And I think that actually the other thing I want to stress is that maybe something we need to, as an agricultural community, we need to think about is the enormous value of large curated data sets. Now, we have a lot of information coming out of farms because people measure the productivity, the number of eggs or whatever they do, whatever the animal they're looking at. But not really very much is done with it. And so the benefits of collecting lots of data, I don't think have been realized within the agricultural community nearly as well as it might have been. And I think we can take a leaf out of what human medicine has done For example, the UK Biobank has been set up with the absolute specific aim of being able to have a large data set that people can interrogate, do the statistics, in future let AI loose on it. But the point that I think is important is how beautifully this data set is curated. For example, if you're looking at activity, they've taken the care that for 100,000 participants, they've actually measured with a standard wrist-worn activity monitor how much physical act they do over a 7-day period. So if somebody wanted to find out the relationship between activity and some kind of health outcome, they would know that they were comparing like with like. They could know that they could compare this. It's not just a kind of vaguely questionnaire. People said, oh, I'm active or I'm inactive. It's beautifully curated data. It means you can go into this data and ask really what sort of what was done, how was it collected, which means you can avoid the worst problems of confounding variables because it's all laid out there. And so it means that there's brain imaging, there's heart imaging, there's whole genome sequences for 500,000 people, and so on. It's a brilliant resource, and we have obviously we have nothing like that. And then people can begin to ask important questions like, could we look at the effect of COVID-19 on the brain? Are there markers that we could use to predict Parkinson's earlier? And you could see you couldn't begin to ask it unless you had this really good database. And it seems to be a great pity that in agriculture, lots of data is collected, but it's not collected in a standard way, and it's not put in a form that we could interrogate it. For example, we might want to ask, what's the effect of reducing antibiotic use on something? And instead of doing a small scale study, we ought to be able to look at a very large data set and make much broader scale analyses and get real answers to questions like that. So I think that's one of the things which I hope the future will bring. So I'm going to conclude by saying that I think smart farming has a huge potential for improving animal welfare, because it can potentially improve two key elements of animal welfare: the health of animals by giving continuous monitoring with early warnings, which is going to be really important for reducing too much medication. It gives better control over environmental conditions, keeping animals in situations which are optimal. And it potentially, we could use big data to understand best practice, not just I've done a small scale experiment or this company's done it this way, but actually across a broad range of types, what is the best way for a given outcome. And secondly, it has the potential for giving us a much more animal-centered view of agriculture. In other words, provide information what animals want, not just what people think animals want, but what animals really do want, which means that we could input into animal-centered design and even allow animals to change their own environments. But as I've said, that we need to make sure that that potential is actually fulfilled and that animal welfare is made a priority, does become an essential part of smart farming, which I think will depend very much on demonstrating the welfare value in practice, but also demonstrating the other benefits that can accrue from improving welfare, such as reducing mortality, increasing the health of the animals, so that we actually, animal welfare is seen as part of the win-win of new technology, not as something in conflict. As I said, there may come conflict, but I think there's a lot to do of actually establishing the financial, environmental, and other benefits of technology. But we've got to actually demonstrate it in practice, which perhaps means closer collaboration between research and industry. And I would hope that we will see in the future the development of large data sets and AI to constructively deliver best practice based on really good, widespread evidence and high quality data. So I'm going to stop there. I hope there'll be time for questions, and I'd like to thank my collaborators for that. And thank you very much for listening.
Thank you so much, Dr. Dawkins. Let's give a round of applause to Professor Dr. Dawkins. We have some time for asking questions. I invite Dr. Stacey to read the questions that asked in the chat window.
Sure, yeah, we've had a few come in during the talk, and then also if you want to add questions, please feel free to do that as we go. So the first question is, and I think you might have covered this a little bit, but maybe you could expand on it. Can you provide examples of successful case studies where farm technologies have positively impacted animal health and well-being?
I think some of the best examples are in the dairy industry, where everything is really very much focused on individual animals, and particularly where you've got the animals would be tagged, they would go into the milking area, they would be weighed, their feet would be the evenness of their feet, the evenness of the udder, there were changes in the udder. And I think this really is really important, and is a very good example of that. I think what I was saying about the health is that surprisingly in the broiler industry, which is where I work, and there's relatively little of that, and that's, I think, a pity. I hope that's something that's going to be rectified quite soon.
Yeah. Another question was, how do we bridge the gap between understanding what animals want and need, and then actually caring enough to ensure that those needs are met? So, for example, as you mentioned, that it's known that cows show parts of the white when they're in fear and anxious and in distress. But and we know they do this, like when their calves are removed, but yet we still remove the calves. Or in the pork industry, there's still wide use of farrowing crates, where we probably pretty sure that sows really don't want to be kept in that kind of constrained environment. So how do we balance that?
Well, the farrowing crate one is difficult, because you've actually got a conflict between the sow and the piglets often. That the farrowing crates were designed to stop the sow lying on the piglets, so there's a bit of a conflict there. But I think, yes, you're right. I mean, that we do things to animals that if they were left to their own devices, they wouldn't want to happen. There's also, you're quite right, that there's a potential distinction between what animals need and what they want. And I think this is actually quite interesting. It's why I think that you can never go below those two questions. What do animals need? What keeps animals healthy, and what do they want? Because what keeps them healthy, what they need to keep them healthy, might actually be in conflict with what they want. For example, if you gave dogs and cats all the food they wanted, they maybe become obese. Now, the reason for that is actually quite interesting. It is that we put a lot of animals, like dogs and cats, in an unnatural environment, not the environment in which they evolved. So, for example, the ancestors of dogs, of say, wild dogs, had a situation in which most of the time when they chased food, they were unsuccessful. So a strategy of eating whatever you come across because you don't know whether you're going to get another meal is highly adaptive if getting enough to eat is very difficult and you're likely not to be successful. Put that same animal into a domestic environment in which there's plenty of food and they will overeat. It's a mismatch between what they were evolved for in their natural environment and the difference between the environment which the domestic environment in which they find themselves. It's no different from us either. I mean, there's a conflict between, children don't want to go to the dentist. I mean, there's a conflict between what you need and what you want. That's why I think you always have to ask those two questions. And you can I think you can go below 5, but you can't go below 2.
I think another aspect of that question was really the balancing of the animal needs and wants and the economic drivers of the food and farming industry. So definitely, I think one of your last points was about showing the value on the practical side of not just the health and welfare benefit to the animals, but also if we did introduce technologies that could improve their welfare, that there has to be, we have to be designing them with these other aspects in mind. So what are the benefits of from the business side, because we know that farmer is definitely a business. Another question that came in was, when thinking about large data set collections and different methods of animal rearing across the world, how useful are comparisons from these different systems?
You mean how easy is it to compare free range or intensive systems?
This question came in from Rachel, so perhaps she could clarify what she's asking.
Yeah, so when I'm thinking about this, I'm thinking about different animal systems. So if we're looking here in Western Canada, we have very large feedlots out here with lots of animals in a pen. Whereas if we go into Europe, we may only have a few animals in a pen, right? So how useful is that data in, maybe collected in Italy to somewhere here like in Western Canada?
Yes, no, I agree. Well, I think if we could agree on the signs of good welfare, you could ask the question, where do you get good welfare? So that would go across systems. You could argue, well, in one system, you're giving animals more of what they want, or in another system, you get better health. And I mean, it's very difficult to actually equate those because very often you might say, in free range, for example, you might say, well, you're giving animals more of what they want, but then you might find higher mortality. I mean, that's just a very difficult equation to make. But I think if we agreed on some outputs, people at least would be in a position to say, well, in this system you get this output, in this system you get that output. They might disagree about the value of freedom to be outside versus mortality or whatever, but at least the data would be there. So I think that it seems to me you're absolutely right. It would have to be system specific, but I still think an awful lot could be done to make some comparisons useful.
Another question that we had come in earlier was, what do you see as the challenges or limitations associated with implementing digital solutions for animal welfare in farming? There's key challenges you've definitely talked about, but can you just reiterate some of the ones that you think are the most important that the community really needs to address. Maybe take an example in the broiler chicken situation.
Yeah.
You said there's not that many technologies in use there now. What do you think is stopping that?
I think there are two things. One is that there aren't clear indications of welfare. That's one where I think we do need to do some work on that. The second one is that even when we do have indications of welfare, you might take hot burn, or you might take some mortality, or whatever it is. Very often we don't have the evidence. We've got a lot. You've got a lot of people saying, "Oh, well, you ought to give them this. They ought to have perches. They ought to have this. They ought to have that." And one of the things that really I think the producers find very difficult is, well, what's the evidence? It might make the people feel better if you gave them something, but what's the evidence that it actually makes the animals healthier, or that the animals actually want it? And I think it is actually, that is one of the challenges. That's the first challenge. The second challenge is that in most cases, the agricultural industry is not an industry where there's lots of money floating around. A lot of people are really up against huge financial constraints, fuel prices going up, feed prices going up. And with the best will in the world, they've got to see that there is a financial benefit to what they're doing. So I think my experience of talking to producers is that they're prepared to be flexible, but they want good evidence, which is often not there, and they want to know what all the implications of something are. We've got to look at this. I mean, for example, you introduce an enrichment and you find that it increases mite infestation or something. I mean, you've got to look at absolutely everything. And I mean, one of the problems is that a lot of university research is done on a small scale, and it just doesn't scale up to where, all the constraints of, I don't know, if people switching off the electricity when you don't think they're going to, or all the problems that you run onto a real farm. So I think that another constraint is that we need more wide-scale field trials.
I definitely agree with that. And I think even across different livestock sectors, we see different amounts of profit margins. So here in Canada, dairy industry is regulated. We see a lot more technology on those farms because those farmers, they get the regular milk checks. They can plan ahead.
Yep.
Look, and the average beef farm on Canada has almost no technology. So we definitely see the impact of the economic situation, but even across sectors, there's differences there.
No, I think you're absolutely right. And I mean, in Britain, for example, I mean, there's no subsidy at all for chicken farming. I mean, they're operating on very small margins.
Yeah.
There is a question from Sean Tibbets. He's asking, do you think plasma cortisol levels still play a role in the assessment of the state of an animal's welfare? So we go about doing biochemical tests all the time.
Yes.
Do they
Yes.
have any role in terms of the welfare assessment?
I think they do have a role. The trouble with plasma cortisol measurements is that they don't tell you whether the animal is aroused because it's fearful and wants to get away from something, or whether it's aroused because it's really excited and it's about to be given something it wants. It doesn't have valence by itself. And so I think one's got to be a little bit careful. I think you need additional information in addition to just the levels. You need to know whether the animal is excited because it's getting something it wants, or fearful because it's getting something that it doesn't want. So I think you need extra information. Very useful, but it can be misleading if you use it on its own.
We have another question. One of our participants is coming from the inclusivity community and is asking questions about the value of the research we've been talking about in this industry for peoples of disability, perhaps even ways for people with disabilities to participate in the research and benefit from it.
I'm hoping that a whole new raft of people will be attracted into agriculture, that people who actually enjoy technology, I mean, and that they, you know, you won't have to do massive travels through a chicken house. You can actually monitor what things without doing it. It'll actually become easier, and it'll attract people who are interested in technology. It'll make the life of a farm manager physically easier, and therefore that will improve. That will increase the inclusivity. I think it is potentially could make the environment in which farm managers and farm staff have to work much easier, much pleasanter, and give them more time to really think about what's going on.
Thank you. Maybe we'll take this as our last question.
Yeah.
Rachel has a second question. In industry, we do a large amount of large-scale research that is often focused on efficiency, but not necessarily welfare. Can you comment on how to integrate welfare measures into these trials?
Well, one of the things I'm hoping is that the welfare technology that we're developing will just plug into existing controller systems. So if you have a controller system that is currently looking at feed use, temperature, humidity, that you could actually have these welfare measures going alongside, so that when the farmer looks at a screen, you could scroll down and see all these other measures that he looks at the moment, that everything's going on well, and the water use is fine, and the temperature is fine, and that he would scroll down and be able to see the welfare as well. So I think the future is integrating welfare measures into the existing controllers, which are already quite complicated. But I think that it should just be you plug it in like an extra sensor.
Okay, thank you. I think we're going to wrap the session up now to make sure we can get everything set up for the next talk. But that was a really amazing talk. Thank you so much, Dr. Dawkins. There was so much information there for the audience, and I think that you brought a lot of really interesting perspective on thinking about how to make things practical going forward, and how we can actually take real world steps to thinking about how to improve, and not just thinking about, but actually making improvements to animal health and welfare on the farm. So thank you so much. And I invite everyone in the audience.
Thank you.
Thank you, Dr. Dawkins.